Okay, guys, let us consider this typical exam question that we are given on our AC theory, working with the three-phase. So the first part, we are just given 7.1. Copy the following table into your answer book and then fill in the blanks. So we are given like the symbol that you're going to use, the quantity that you have, and also the SI unit. So we've got the true power, the apparent power, and the reactive power. So remember the true power, that is P, and the SI unit for power, that is the watt. Okay, so power measured in watts, or it can be given as the kilowatt. The apparent power, remember, that is S. The symbol for apparent power is S, and measured in volt amperes, or this can be kilovolt amperes. What about the reactive power? That is Q, and this is measured in volt ampere reactive, or that is the kilovolt ampere reactive. So we're going to have the R there representing the reactive power. So that was 5 marks, just like that, 5 marks. So guys, please do revise. Don't just take anything for granted in your revision. Anything is important. Remember, this is a 10-mark question. So you've got half. Out of 10, you've got half. You just left with 5 marks. And the 5 marks on the calculation, what is it that you're given? A 60 kilowatt, 525 three-phase star connected induction mode A6AA. I talked about that. Once you're given a motor that you're given as this certain power, that is the power output. So you've got a 60 kilowatt, that is the power output. 525, that is the line voltage that we are given. Three-phase star connected induction motor. It is in a star. Remember, we talked about a typical question where we can have both the star and the delta, but this one is in a star. With a full load efficiency of 95%, that means our efficiency in this case is 95%, that is 0.95 if you divide by 100. Takes a phase current of, so that is the phase current of 75 amps from the supply. Remember, in a star, I talked about this. You need to understand your connections, the star, the delta, and what is it that is common between the two. In a star, it is the line current and the phase current, which is the same. The voltage is actually different. Remember, guys, we talked about these diagrams, guys. I'm not gonna keep on drawing this. Check the first revision that we had. So this is, remember, your star. So in a star connection, the line current and the phase current are the same, but the phase, this line voltage to the phase, it is to be multiplied by 3. The phase has to be multiplied by 3 to give us the line voltage. Okay, that is what you have to consider. So it was just a direct question, nothing much, guys. All right, 7.21, the phase voltage of the motor. We need the phase voltage already. We are given the line voltage, so we can relate from this formula, the 7.21. From this formula, if we are to make VP the subject, it means VP is equal to VL over the square root of 3, where VL is the line voltage of 525 volts. So divide by square root of 3, that was going to give us the phase voltage in this case, and that was going to be 303,109 volts. So thus we've got the phase. Let us consider 7.22, the power factor at which the motor is operating, the power factor. The power factor has to be taken from the power, so it means we must relate this to the power. That is where we can have the power factor. Remember, the input power is equal to the square root of 3. This is three phase that you're considering. So the square root of 3 times the line voltage times the line current times the cos of theta, where the cos of theta is the power factor. Yes, we can now conceive. We can also talk about the when it is in three phase. I mean, when it is in phase, 3 times VP times IP times the cos of theta. You can use that. Anything that you want. Anything that you want. So in this case, we can take advantage of the line because already we get anything that you want, even the phase, because you have the phase voltage. Guys, use anything that you want between the two formulas. But we do not have the input power. We have the output. So where are we going to obtain the input power? Remember the relationship from the input and the output efficiency and the input power, that the efficiency is output over the input. So from this, it follows that the input power is going to be P out over the efficiency. Remember, you're going to cross multiply, then divide by the efficiency. So that is the input power can be calculated from the output power, 60 times 10 to the power of 3, over the efficiency of 95%, which is 0.95. So this was going to give you the input power. In this case, you're obtaining the input power. That was 63,153,895 watts. 3 decimal places. All right. So with our input power, remember what you need is the power factor, which is the cos of theta. So the power factor, which is the cos of theta, if we are to make it the subject, it means we're going to divide these to the power input. So that is the input power over, we divide by the square root of 3, the line voltage and the line current. So it's going to be the square root of 3 because we are dealing with the line. If you're working with the phase, you just use the 3 as it is when dealing with the phase. So everything is there. We can calculate our power factor, which is the cos of theta. Do not forget, guys, this is cos of theta representing the power factor. So that is from the input power that we got 63,153,895 divided to, that is the square root of 3. Guys, why am I forgot to erase this while at least I was illustrating something. This is still the square root of 3. So you've got the square root of 3. Remember, your line voltage, that was 525. So this is 525 times the line current, remembering that we are in a star connection, and in a star, it is supposed to be understood that these two are the same. So this is equivalent to the line current, which is 75 amps. So we have got the line current from that. So that is 75. So that was going to give you a power factor, which is 0.29. It was going to be 0.926. Okay, so remember, this is an inductive motor, so it's going to be lagging. That is how you can calculate your power factor from there. That was just 2 marks, and 7.23, the line current of the motor. So guys, we are asked something that we have already used in these calculations. Remember, I said the line current and the phase are the same. So the 7.23, our line current equal to the phase current was going to be 75 amps. Okay, so these are the typical questions that you are going to be actually given on a 3-phase or working with the 3-phase systems. It can be a delta connection. It can be a star connection. You need to understand the difference between the two and the formulas that you're going to work with. But that is what you're going to work with in our N3 as long as to deal with a 3-phase. So shall we have typical exam questions from other questions? As we move on, just try to revise as much as you can.